Hello, everyone. This is Yao Yao from Xiaomi. It's a great pleasure to join this year's online workshop. Today, I would like to take the opportunity to introduce a project we've been working on. It's called Xiaomi Vela. It's an IoT operating system built upon NuttX. Briefly about myself, my background is mostly in embedded system design, especially in the wireless and IoT domain. I joined Xiaomi about a year ago, and before that, I was with Texas Instruments and Google for several years, both working on IoT-related technologies. And in Xiaomi, I'm responsible for leading the Vela project, as well as a bigger effort for building Xiaomi's IoT consumer IoT platform. My talk today consists of four parts. First, I want to introduce Xiaomi and Vela. I will talk about who Xiaomi is and why we have to develop Vela. And after that, the organizer of this event asked me to give a quick introduction for people who are not familiar with NuttX. So for the second part, I will give a brief introduction about NuttX and talk about why we decided to use it as the foundation of our system. And third, I want to talk about the approach we're taking while building Vela. I will also present the latest status of the project, including what products have we launched with Vela inside, as well as our future plans. Last but not least, we have made lots of important enhancements to NuttX along the way. I want to talk about those enhancements and introduce the team who has been working on it passionately. Let's dive in. First, I want to take a few minutes to introduce Xiaomi. Xiaomi is a Chinese company founded in year 2010. We started as an Android smartphone maker and later became one of the leading smartphone provider worldwide. And just recently, in the past quarter, we became world #2 smartphone brand in terms of global market share. And besides the smartphone business, we have been quite lucky in the consumer IoT space as well. We are one of the largest consumer IoT platform worldwide, with 351 million connected AIoT devices. And this number doesn't include smartphone and laptop. Our users are also very devoted to our ecosystem. We have 6.8 million users with 5 or more devices connected to our AIoT platform. We also have an app called Mi Home app, which serves as the main interface for user to configure and control their devices. We just reached 49 million MAU in March this year. And this next slide is another marketing material, which I'll go over quickly. Xiaomi maintains AIoT leadership across lots of key product categories in mainland China. We have #1 market share for smart TV. We are #2 for smart band and #3 for T-device earbuds. We're also very strong for smart appliances and home security. Our air purifier and smart door lock are selling very well, both #1 market share. We're also a major smart speaker provider in China and rank #2 with about 30% market share. So that leads to our next question. Why do we need to develop Vela? This picture shows a tip of the iceberg of the problems we're dealing with on a daily basis. A huge but deeply fragmented consumer IoT market. We have over 2,000 SKUs, ranging from very simple devices to much more complex applications. Our cheapest BLE home temp sensor costs less than $5, but even our low-end smart speaker runs on an SoC with 4 heterogeneous cores. Not to mention some of the high-end devices with more complex functionalities. So we desperately need to build a common software platform that unifies all these. Since late 2019, we have been developing an IoT OS that serves as a common software across all IoT applications, and we named it Vela. Vela is built upon NuttX, kind of similar to how Android is built upon Linux kernel. For the initial phase, we will focus on 2 major subdomains of the consumer IoT space, the smart home and the wearables. We will first enable smart home, smart appliances, smart speaker, and smart sensor devices. as well as smart band, smart watches, and earbuds. And these applications require lightweight and scalable operating systems with good low power support. Vela and NuttX are perfect to serve those needs. So that's a brief intro about Xiaomi and Vela. Next, I want to give a quick introduction to NuttX for people who are not familiar with. NuttX is a real-time operating system developed by Gregory Nutt. As its name indicates, NuttX is a Unix-like operating system, and we like to think of it more like a tiny Linux. The APIs and development environments are very similar to Linux, but it was completely written from scratch and optimized to be much more lightweight. It was first open sourced in 2007 under BSD license, and later undergo incubation by Apache Foundation in 2019. So where is NuttX used? NuttX has been used in lots of areas. Sony has used it in its digital audio recorder, and Fitbit has used it in its fitness trackers. PX4 and MicroROS are two open source communities for drones and robots, and they both heavily use NuttX. NuttX was also forked by Samsung's Tizen RT and Google Aero project. We as Xiaomi are also using it in many consumer IoT devices, and I'll talk about the details in later slides. So next, let's talk about why we choose NuttX. We actually did a little bit shopping and compared all the popular RTOS. The number one reason we chose NuttX is because it is standard compliance. Here, the standard is mostly referred to POSIX compliance. In this regard, NuttX is quite unique, as a lot of the RTOS claim to be POSIX compliance, but most of them just wrote a wrapper layer for the pthread APIs. And NuttX is the only one that is designed from scratch as POSIX compliant. This is quite important for modern RTOS, as porting effort for existing Linux programs and libraries can be minimum. This also makes it very easy for Linux developers to adopt NuttX as a cost-down and real-time alternative for a Linux-based system. The second reason for our decision-making is NuttX is designed to be extremely modular and scalable. With kconfig getting integrated into the entire system, NuttX can be very elastic and perfectly meet our needs to scale from low-end simple device to high-end complex systems. Third, NuttX supports very rich kernel features and support lots of advanced OS functionalities. And reason number 4, as I mentioned previously, NuttX is a mature system and it's been used in many products. It's also available on almost all the major embedded platforms, such as the ARM A&M series, the Atmel AVR, the microchip MIPS, as well as RISC-V and Expressive ESP series. You can get the full list of supported model and boards from the NuttX Apache website. The maturity and availability of an RTOS is definitely essential. Reason number 5, symmetric and asymmetric multiprocessing are big trends for modern embedded systems. And NuttX is unique as it has good support for both. In fact, the Vela team contributed the NuttX AMP framework, and I'll talk more about it later. And reason number 6, NuttX is currently under Apache 2.0 license, a very open license. It's easy to contribute and redistribute. And the last reason is very important. NuttX has a very active developer community, and people are doing great work together to make NuttX great. So that's a quick intro into NuttX. Next, I want to talk about the Vela approach, progress, and plans. Okay. So this picture shows the overall system diagram of Vela. The bottom yellow part is the NuttX kernel. It provides the basic OS functionality, such as scheduler, IPC, file systems, network stack, and device drivers and power management. For this part, our development guideline is we will stay in sync with NuttX mainline as close as possible. So it means we will do a sync with the mainline about every 2 months, and we upstream our changes back to the mainline as much as possible. The green section above the NuttX kernel is the Vela application framework. The way we plan to tackle the fragmented IoT space is by making Vela modular and scalable. And we see this application framework as a middleware. It's a collection of libraries, utilities, and frameworks that enable various IoT applications. For example, we designed a multimedia framework to support playback and record functions with flexible filter graphs so that application developers can quickly spin off a smart speaker or earbuds application. We developed a sensor framework which decouples data source and data algorithms with specific low power considerations to enable wearables applications. We also support various SDKs. For example, IDM is short for Intelligent Device Mesh, and it's a Xiaomi interconnect protocol for discovering and communicating over local Wi-Fi and Bluetooth connections. Cloud SDK is used when communicating with Xiaomi Cloud, and AI SDK brings Xiaomi ASR and NLP capability to embedded devices. The lower row of the application framework are some common utilities and libraries, such as the Bluetooth stack, which includes BR-EDR, BLE, and BLE Mesh stack. And in the future, we'll also support BLE audio. We provide various OTA options, key value database, an RPC framework, GUI library, and GS engine and security engines. And we will continue to extend the capability of Vela application framework to serve more and more IoT applications. The green section in the right covers the tools, including IDE and GUI designers, PC emulators, auto test frameworks, and the usual logger and debuggers. Since we have limited time, I won't go into details about each one, but these actually are quite essential for developing in an RTOS system. So they probably deserve a dedicated session next time. So that explains the approach we're taking for developing Vela. Next, let's talk about the progress. Last year, we launched the first Vela IoT module. It's a Wi-Fi and BLE dual mode module. And manufacturers can embed this module into their devices, and they will automatically acquire the capability to provision their device onto a Wi-Fi network, connect to the Mi Cloud, as well as interact with other devices from the same ecosystem. Right, so our system turn off the lights. Since then, we have empowered 12 different IoT devices. Some of them are quite interesting. Even I didn't expect them to exist, like the knife sanitizer. But just want to give you a general idea what kind of products do we make. I listed some of them here. Okay. All right, so this year we have been focused on this new application, and we just launched our first Vela speaker on August 3rd. It's not just a smart speaker, it's also a universal IR remote. You can use it to voice control your TV and air conditioners. It also acts as a smart home mesh gateway, so you can voice control your smart lighting system to set up the movie mode, or your vacuum robot to start cleaning the house. It's quite sleek. And talking about future plans, next year we will extend the Vela capability from smart home applications to the wearables. we kind of we kind of see Vela as a little girl. So I put a little girl's picture up there. As we extend or expand to new application areas, this girl just naturally grows with more capabilities and accomplishes more. So that's how we view it. So that closes the third part of this presentation. Last, I want to talk about some of the key enhancements we made to NuttX. We have been contributing to the NuttX open source project since year 2017. Along our journey, we have made some important enhancements to NuttX, and we summarize them in 7 categories. We contributed the NuttX AMP framework. We are also key maintainers for simulator and other ARC support. We enhanced the file system and drivers. We also optimized system performance and improved the debugging experience and developed some new debugging tools. And I'll talk about each one in a little bit more details. And let's talk about AMP first. AMP is short for asymmetric multiprocessing. In the current IoT world, the heterogeneous multi-core architecture is becoming more and more popular. It has significant advantage in achieving a good trade-off among performance, cost, and power consumption. OpenAMP is an open source implementation and commonly used on non-Linux systems. We are a key contributor to OpenAMP, and we developed zero-copy and two-phase handshake features for OpenAMP. We also ported OpenAMP to NuttX and actively maintain it. OpenAMP establishes a low-level messaging channel between multi-cores via shared memory, and it's called RP-Message. We implemented upper-level services on top of OpenAMP RP-Message to provide syslog, TTY, hostfs, network, user sock, and other capabilities so that it can be more useful for application developers. The second enhancement I want to talk about is the debugging capability, which is normally a weakness for RTOS versus larger systems. 2 parts of our work are worth to mention. One is the NuttX simulator. We developed a lot of key sim drivers such as SMP, audio, frame buffer, network, Bluetooth, and so on. With these enhancements, developer can run their application code along with the NuttX systems and emulate a complete multi-core device on a host machine. With some advanced debugging tools on the host, developing on a simulator can greatly speed up application development. We also enhanced NuttX debugging tools. We ported ASUN and UBSUN to NuttX, so memory corruptions and stack problems can be debugged more easily. We also implemented backtrace and dump functionalities. The debugging experience is a lot better now with all the contributions from the community, but it still didn't fully catch up with bigger systems like Linux yet. So we would like to shout out to the community and let's be more creative and work on it together. And for people who are interested, since we don't have enough time to go over each one by one, here is a non-complete list of the major features we contributed to NuttX. And I'll just quickly go over some of the major points. So I already talked about number 1 and number 2. And number 3 is enhancement to the NuttX file system. We unified the socket and file interactions so that socket are also using standard FD handles underneath now, and you can do a dupe of sockets as well. And number 4, we enhanced NuttX driver system and unified sensor driver model, and we developed some testing tools. And number 5, we did lots of system optimizations. We boosted ELF loading speed by 100 times. We also enhanced the NuttX TCP/IP stack and improved lots of key networking performance for actual user scenarios. And number 7, application-wise, we are little VGL committer and are actively maintaining LVGL in NuttX. We are also member of the Walmart Technical Steering Group and ported and maintained Walmart and Wasm 3 WebAssembly engine. Okay, so that's a quick recap. And for people who are interested, feel free to reach out to us for more information. Okay, so last, I want to introduce the Vela team. This is our team, and we have about 20 people now. Some other team in Xiaomi also support us, so it's a collaborative effort. Xiaoxiang, whose picture is on the bottom left, is our chief architect and leads the overall technical work. He is also very talented and has committed over 1,200 patches to NuttX. Last, I want to say we greatly appreciate the opportunity to work with the NuttX community and appreciate all the open discussions and helpful advices from people in the community. It's definitely very open and collaborative, and hope we can continue to work closely together and let more people to know about NuttX and adopt NuttX to benefit their products. And for people who's online watching this video, welcome to join the NuttX community, and we welcome more people to join us and make NuttX great together. Okay, so one more slide. Thank you for staying till this part. This is the Easter egg part of the talk. And in this part, I want to briefly talk about why we take the name Vela. We always envision the IoT space to be a big ocean of devices. There are just so many of them. So we wanted to find a name that is associated with the meaning of ocean. And Vela in Latin means sails of a ship. It is also a name of a constellation in the southern sky that is in the shape of a sail. It sounded nice, so we picked it as a name. And now we can see ourselves as a sail in the sea of IoT devices, I guess. And one more quick story, last one I want to share with you. When we first talked to Mr. Gregory Nutt about Vela, he actually gave us another interesting point about the name. It turned out that Vela also means candle in Spanish. And there is a famous saying in Spanish that is very interesting. I put it on the slides up there. And for people who are interested, feel free to Google it. Wisdom from our man, Greg. All right, finally, this closes my presentation today. Thank you very much for your time. I put my email up there, so please feel free to shoot me any questions if you have. Thank you very much.